In fifth grade, students continue to build their reasoning and understanding of multiplication, specifically around some more sophisticated operations and some more sophisticated arithmetic with fractions. And in fifth grade, that includes the multiplication of fractions. And oftentimes, this can be another area where it might be easy just to teach a rule that students can kind of memorize, get the right answers, and move on. But what we find later on down the road in sixth grade, seventh grade, and eighth grade is that as we continue to add rules and more rules and more rules, they start to blur together. And if students haven't made the connections and haven't built the understanding, they don't really have anything to fall back on. And so rather than starting with just teaching a rule of let's multiply across 2 times 3 and 3 times 4, we can use some strategies or some models or some strategies and models together to build that understanding of what it means to multiply fractions. And in this video is going to be a little different than some of the others where our focus is very specifically on the strategy and we're just using a model to represent that strategy. This video is really going to focus on using the model to help make sense of the operation of multiplying fractions, because it can be kind of a weird thing to multiply something by something less than 1. We want multiple groups, but the amount of groups we want is less than 1. It's kind of a strange question. And so we can use this area model to help make sense of that. And so what I'm going to do is start with 2/3, and I'm just going to model that. Looks a little bit like a bar model at first. I'm intentionally starting out as a square, and you'll see why in just a moment. It doesn't have to be exactly a square, but something a little taller than a typical bar model when we're representing fractions. And I'm going to split this into thirds and just shade in 2/3 of this. Now, one of the most important parts of this is understanding what it means to ask 2/3 times 3/4. And as we're teaching this with students and as we are modeling and representing this thinking and using this area model, the way we want to sort of ask the question is 2/3 times 3/4 is asking what is 3/4 of 2/3. And to find 3/4 of 2/3, that's where this model comes into play and can help us make sense of that question. Because here I see 2/3, and I want to know what 3/4 of this 2/3 is. So going the other direction, I'm now going to show 3/4 on this same model. So I'm going to draw my fractions going the other direction so that I can shade in 3/4 and not interfere with the 2/3 that I already have. So now I'm going to go in and shade in 3/4. And then here is where I can sort of ask that question, what is 3/4 of 2/3? And where we see that at in this model is this space where both 2/3 and 3/4 are shaded. We're seeing 3/4 of the 2/3 in this 1, 2, 3, 4, 5, 6 of the pieces. So 3/4 of 2/3, we have 6, but remember this square on the outside, that was one whole. So it's not 6 wholes, we have 6 parts of something. So we need to know 6 parts of how much. And now we just have to look at what our total parts are in the square. And so we had 3, 6, 9, 12 total parts. And so 3/4 of 2/3 is 6/12. We could also write that as 1/2, but understanding equivalent fractions and getting other equivalent fractions with smaller numerators and smaller denominators isn't the focus of building that understanding right now. So I'm just going to leave it as 6/12. 3/4 of 2/3, or 2/3 times 3/4 is 6/12. So let's look at that with one more just to see it again. I'm going to find 5/8 times 1/5. And again, I'm going to think, what is 1/5 of 5/8? So I'm going to start by representing 5/8. So I'm going to break this into eighths. 1, 2, 3, 4, 5, 6, 7, 8. And I need 5 of them. So that goes over to this mark here. So here's my 5/8. And now what I want to do is on top of the 5/8 represent 1/5 because we need 1/5 of the 5/8. So I'm going to break this into 5 parts and then just shade in one of those 5 parts because we only need 1/5 of the 5/8. And so that's just one right here. I could have shaded the top, the bottom. I could have shaded it anywhere I want. I don't have to shade from the top to the bottom, from the left to the right. It just keeps it organized for me. And our product, 1/5 of 5/8, is represented in this section where both are shaded. And so we have 1, 2, 3, 4, 5 of them. And how many altogether? 5 of how many parts? Well, I know that across here I have 8, and down here I have 5. So the area of that, those unit cubes in there, if students remember back from 3rd grade, when they first start thinking about area of rectangles, they think of it as unit cubes. So there's 40 of them in here. So this is 5 over 40. And again, I'm not going to worry about writing that as any other equivalent fraction. 5 over 40, 5/40ths is perfect. And what can be great teaching this strategy and this model is students might actually sort of derive the algorithm of just multiplying the numerators, multiplying the denominators on their own. Once they see this enough, they might start to recognize, hey, every time the numerator I get is just the product of my other numerators, and the denominator I get is the product of my denominators. Can I just do that and not draw the model every time? And we can challenge students. I don't know, let's test it out. Why don't you get the product first, then check it with your model and see if it works. And eventually they will kind of generalize that idea on their own. And then instead of being a rule that they just memorized, it's something that they can truly own and understand. And so that's using the area model to multiply fractions.